Good morning, student. The subject Introduction to MEMS. So here we are going to start the chapter number 4, that is Micromachining. So I am Madhuri Mulik, working as assistant professor in Department of Electronics and Technology, Sharal Institute of Technology, College of Engineering. So let us start with the fourth chapter, that is Micromachining. So in the previous 3 chapters we have seen Introduction to MEMS. Then after that we have seen that the controls and materials which are used for MEMS, and in third chapter we have seen the review of that, the basic fabrication. Now in micromachining, fourth chapter, again we are going to see the fabrication process in detail. So let us see with that the micromachining. So for the MEMS, so which are the steps of the fabrications? So let us see. Micro electromechanical system is a system of miniaturized devices. Okay, so name itself indicates that it is miniaturized devices and structures that can be manufactured using microfabrication techniques. Okay, that can be manufactured using microfabrication techniques. So it is a system of microsensors, microactuators and other microstructures fabricated together on a common silicon substrate. Okay, fabricated together on a common silicon substrate. So a typically MEMS system consists of a microsensor that senses the environment and converts the environmental variable into an electrical circuit. So the microelectronics process the electrical signal and the microactuator accordingly work to produce a change in the environment. So fabrication of MEMS device involves the basic IC fabrication method along with the micromachining process involving the selective removal of silicon or the addition of other structural layers. Okay, so which are the steps in the fabrications of MEMS? So MEMS is nothing but the micro electromechanical system in which miniaturized devices and structures must be fabricated using microfabrication techniques. So which structures come over that in that MEMS? What are the basic or common things? Microsensors, microactuators and other microstructure, okay, which is fabricated on a single substrate. So typically it consists of microsensor which sense the outer environment and that environmental variables convert into the electrical circuit. Then that electrical means must be processed. So microelectronic process the electrical signal and microactuator accordingly work to produce a change in the environment. Okay, so means what? From this picture it is clear as that fabrication of MEMS device involves the basic IC fabrication methods along with the micromachining process. Okay, means fabrication of MEMS device involves the basic IC fabrication method along with the micromachining process. So involving the selective removal of silicon or the addition of other structural layers. Okay, selective removal of silicon or maybe there is the addition of the other structural layers. So micromachining is classified into two types, whether it is the bulk micromachining or whether it is the surface micromachining. So first, that is bulk micromachining we are going to see. So which type of the steps of MEMS fabrication using bulk micromachining? So here in a bulk micromachining, the substrate is taken, over that masking film is there, so coating with photoresistive. Okay, then along to that the photoresist is plastered. So on this photoresist we have to place the mask alignment. So this is nothing but the mask glass, through that ultraviolet light comes, so that this mask through this glass that the rays are passed. So due to that means exposure, then development of that layer as well as the removal of that. So here this type of the shape is formed. After that we have to etch that the masking film. So after the removing of this, so you will get that the last bulk micromachining, okay, which is photolithography. So step number 1, the first step involves the circuit design and drawing of the circuit either on a paper or on using software like PSpice or Proteus. So first step is nothing but the design the circuit and drawing into the proper software, maybe for example PSpice or Proteus. Then in a second step, that is, it involves the simulation of the circuit. So maybe it is computer aided design or photolithography mask, so which consists of the glass plate coated with chromium pattern. Okay, so that is computer aided design. So photolithography mask which consists of glass plate coated with the chromium pattern. So in a step number 3, the third step involves photolithography. So in this step, a thin film of insulating material like silicon dioxide is coated over the silicon substrate. Okay, in the third step, it involves the photolithography. So in that, insulating material like silicon dioxide is coated over the silicon substrate, and over this an organic layer sensitive to ultraviolet rays is deposited. Okay, so over this organic layer sensitive to ultraviolet rays is deposited using that the spin coating technique. So last time we have seen that the spin coating is nothing but the that the spin will rotate in that the its speed, and through the nozzle we are going to place that the liquid. So the photolithographic mask is then placed in contact with the organic layer. Okay, so the photolithography mask is then placed in the contact with the organic layer. So the whole vapor is then subjected to UV radiation. Okay, the whole vapor is then subjected to UV radiation, allowing the pattern mask to be transferred. Allowing the pattern mask to be transferred to the organic layer. Okay, to the organic layer. So the radiation either strengthens the photoresist, weakness it. Okay. The uncovered oxide on the exposed photoresist is removed using hydraulic acid. Okay. So the uncovered oxide on the exposed photoresist is removed using hydrochloric acid. So the remaining photoresist is removed using hot sulfuric acid, and the resultant is an oxide pattern on the substrate which is used as a mask. Okay, which is used as a mask. Then in the fourth step involves the removal of the unused silicon or etching. Okay, the fourth step is removal of the unused silicon or etching. So it involves the removal of bulk of the substrate. Okay, it involves the removal of bulk of the substrate either using wet etching or dry etching. Okay, either using wet etching or dry etching. So in a wet etching, the substrate is immersed in a liquid solution of a chemical enzyme. Okay, so in wet etching, the substrate is immersed in a liquid solution of a chemical agent which etches out or removes the exposed substrate. Okay, which etches out or removes the exposed substrate either equally in all direction, that is known as the isotropic enchant, or a particular direction, that is anisotropic enchant. So popularly used enchant are HNA, that is hydrofluoric acid, nitric acid and acetic acid, and KOH, that is potassium hydroxide. Okay, so in step number 4, the fourth step involves the removal of an unused silicon or etching. So it involves the removal of a bulk of a substrate either using wet etching or dry etching. So in a wet etching, the substrate is immersed in liquid solution of a chemical agent which etches out or removes the exposed substrate either equal in all direction, that is isotropic agent, or a particular direction, that is anisotropic agent. So popularly used agent are HNA, that is hydrofluoric acid, nitric acid or acetic acid, and KOH, that is potassium hydroxide. So in step number 5, the fifth step involves the joining of 2 or more vapors. Okay, the fifth step involves the joining of 2 or more vapors to produce a multi-layered vapor. Okay, to produce the multi-layered vapor, that is we can say 3D structure. So it can be done using fusion bonding. Okay, so it can be done using fusion bonding. So which involves direct bonding between the layers or using anodic bonding. Okay, so it can be done using fusion bonding, which involves direct bonding between the layers or using anodic bonding. So in step number 6, the sixth step involves assembling and integrating the MEMS device on a single chip, silicon chip. Okay, in a sixth step, it involves assembling and integrating the MEMS device on the single silicon chip. Then in a next step, the seventh step involves the packaging, and that is the last step of that, the bulk micromachining of the whole assembly to ensure protection from outer environment, proper connection to the environment, minimum electrical interference. Okay, so packaging of the whole assembly must be ensure protection from the outer environment, proper connection to the environment, and minimum electrical interference. So commonly used packages are metal can package and ceramic window package. Okay, metal can package or and ceramic window package. So the chips are bounded to the surface either using a wire bonding technique or using flip chip technique. Okay, the chips are bonded to the surface either using a wire bonding technique or using flip chip technology, where the chips are bonded to the surface using an adhesive material that melts on heating. So using an adhesive material that melts on heating. So forming electrical connections between the chip. Okay, forming electrical connections between the chip and the substrate. Forming electrical connections between the chip and the substrate. Okay, so that is the last step of that, the micromachining. Okay, so we have seen the 7 steps which are used in the fabrication of the bulk micromachining. Then next is the MEMS fabrication using surface micromachining. So in a surface micromachining, okay, so see here one manufacture of cantilever structure using micromachining is shown. So this gray color shows that the silicon, blue color shows that the silicon on nitrate, red is the oxide, and green is the polysilicon. So at the initial level, silicon substrate is taken. Then over that, deposition of silicon nitride layers to protect the silicon substrate. Okay. Then there is a grow oxide layer on the top of the silicon. Then pattern oxide using mask and UV light. Okay. So oxide layer is patterned. Then deposition of polysilicon layer. Okay. So this will be the cantilever beam, this green. Then remove through the etching the oxide layer that is underneath the cantilever. Oxide layer where underneath the cantilever. Okay. So this is nothing but the surface micromachining, which is forming the layer or removing that the layer. So in surface micromachining, the first step involves the deposition of the temporary layer. Deposition of the temporary layer, that is oxide layer or nitrate, on the silicon substrate using low pressure chemical vapor deposition technique, that is LPCVD. Low pressure chemical vapor deposition technique. So this layer is sacrificial layer and provide electrical isolation. So this layer is the sacrificial layer and provides electrical isolation. Then in a second step involves the deposition of space layer. The second step involves the deposition of the spacer layer. So which can be phosphosilicate glass. Phosphosilicate glass used to provide a structural base. Okay, used to provide a structural base. Okay, in the first step, deposition of the temporary layer, which is by the process of the LPCVD, that is low pressure chemical vapor. In a second step, there is again deposition of the spacer layer, which is phosphosilicate glass, okay, which is provide a structural base. Then in a third step involves subsequent etching. Okay, in a third step involves subsequent etching of the layer using the dry etching technique. Okay, using the dry etching technique. So dry etching technique can be reactive ion etching. Dry etching techniques can be reactive ion etching. So that in the last chapter we have seen all these things. So dry etching technique can be reactive ion etching, where the surface to be etched is subjected, to accelerating ions. Okay, to accelerating ions of the gas or vapor phase etching. Okay, of the gas or vapor phase etching. So in a third step, etching process is subsequented, that is based on reactive ion etching. So in a fourth step involves the chemical deposition. Okay, fourth step involves the chemical deposition of phosphorus doped polysilicon. Okay, of phosphorus doped polysilicon to form the structural layer. Okay, so in fourth step, chemical deposition of phosphorus doped polysilicon to form the structural layer. Okay. So in a fifth step involves dry etching or removal of the structural layer to reveal the underlying layers. Okay. So in a fifth step involves dry etching or removal of the structural layer to reveal the underlying layers. In the next step, that is in the sixth step, involves the removal of the oxide layer and the spacer layer to form the required structure. Okay, so in the sixth step involves the removal of the oxide layer and the spacer layer to form the required structure. After that, the rest of the steps are similar to the bulk micromachining technique. Okay, so after that, the rest of the steps are similar to the bulk micromachining technique. Okay, so means what? We have seen that this bulk micromachining as well as the surface micromachining, where it involves that the various steps of that the deposition as well as the etching, as well as that the formation of that the layer on that the another layer. So these are the two main fabrication process which are used in a micro machining. Thank you.